All right, so the next example is graphing horizontal and vertical lines. Now you can't do a vertical line on your calculator, so I'm just going to have some drawn things already and then just kind of show you what it is. So we want to graph x is equal to a -4 and y equals 6, basically on the same coordinate system to see where they're going to intersect. And so here's x equals -4. So no matter where you're at -4 on x, it's going to be a line. And so that gives you that vertical line here. Now, y equals 6, no matter where you are for x's, it's going to give you 6 is going to be your y value. And so that's going to give you the horizontal line. All right. And so now what they're basically are wanting us to look at is where do they intersect? Well, they intersect at where? 1, 2, 3, 4, -4, and then up 6. So -4, 6 is going to be that intersection point. But again, you can't draw the vertical ones on your calculator. You can only draw horizontal ones or any of them with a different kind of slope, but you can't do that vertical slope because that's undefined. And so you won't be able to do that on your calculator. You can do that in Desmos or something else, but with the calculator, you can't do that. All right. And again, this is just kind of saying what I was saying. That's all the points that are 6 or x equals -4. All right, so horizontal and vertical lines. Write the equation of the vertical and horizontal lines that pass through the point 7, -5. All right, so basically, horizontal line through that has an equation y equals -5 because it's always going to be a -5. And we're going to have x equals 7 is going to be our vertical. And so that's going to be the equation for the vertical. And again, that's because we go back here, this one, we said it was going to be a -4, 6. And so -4 is going to give us the x equals -4. Y equals 6 was going to give us that comma 6 part. And so when you have horizontal and vertical lines through that point, that's what it has to be, the -5 and 7. So x equals 7, y equals -5. Now for 2 points, x1, y1, and x2, y2 on a line, the ratio of the change in y in x is called the slope of the line. Okay, so changing y to the change of x is the slope of the line. Now, in a sense, slope measures the steepness or the tilt of the line relative to the x-axis. So if you think about it, going down, that's going to give us a negative slope. Going up is going to give us a positive slope. Straight across, that's a horizontal or a zero slope. And so that's kind of the things we have to look at here. Now, the change in x is called the run, and the change in y is called the rise. So it's called the rise over the run when we have this change in y to the change in x. So it's a rise over run. So we usually do the y first. So we'll do the numerator first, and whatever it says to do, either positive or negative, we either go up or down. And then the run, we either go left or right, depending on how that works. All right, so if a line passes through the two distinct points, x1, y1, and x2, y2, then its slope is given by this formula, the change in y over the change in x. And again, x1 cannot equal x2, or we get 0 in the denominator, then that's going to be undefined, and so that doesn't make sense. And so that's the equation we're going to use here. Again, this is the vertical change, your rise. This is your horizontal change, which is your run. All right, so if we have a line and it moves up from left to right, then the slope is positive, okay? So we're going to go up and over, up and over. So we're going up positive, right positive. Now, another thing we could do is we could go down and we could go left. And we go down and left, that's a negative and negative divided by negative is positive. So again, it's a positive slope overall, even though you're going down and left. So it doesn't matter which way you go. Sometimes you might start here and the graph is cut here if they're giving you a short little bitty graph. And so you actually have to go down and left to get to the next point instead of up and to the right. So sometimes your graphs are going to limit you on what you can do, either up and to the right or down and to the left. Now, negative slope's opposite. We're going to go from left to right. We're going to have going negative values here. Okay. And so if we think about that, so the rise is going to go down, but we're going to go positive for x's. We're going to go negative for a rise, positive for the run. Okay. Or if we want to look at it this way, we can go negative for the run and positive for the rise, negative for the run, positive for the rise. Each case, it's always got one negative, and so the one negative gives us the negative value for a slope, which is going, down from left to right. And like I talked before, a horizontal line is going to give a zero slope, so there's no rise, it's all just run. And so because of that, you just have a horizontal slope, so your slope is equal to basically your zero. And so in that case, if you want to think about it, what basically you have is you're just going to have some equation, y equals, I don't know, maybe 4. Because you have y equals mx plus 4, but if slope is equal to 0, that means we're not going to go up or down or left or right. It's just always going to be y equals 4, and that's what you get there. And so that's going to be your interpretation of your slope with 0 for your slope. Now, like I told you before, if you get undefined slope, which is, a 0 in the denominator, basically what you have to do is you're going to get a vertical line, and that's what we have here. So it doesn't change horizontally, left or right. It just keeps going indefinitely. So it's just going to go straight up. And in this case, you're going to have something like x is equal to, I don't know, maybe a 3. And so your x is always going to be 3 no matter what your y is. It doesn't matter what your y is, it's always going to be that. And so that's going to be your undefined slope, and it's going to be a vertical line. All right, let's stop there and we'll go to some more.